Welcome to this video. I am Physics and today we are going to be going over how to draw and use graphs. So first of all, we are going to be looking at a line of best fit example where the question is determine the stiffness of the spring. And on the left we have a graph which has a y-axis of force and an x-axis of extension. So we know that the formula is F equals kx, and as we want to find k, F over x will equal k. And the formula will be force over extension equals k. So we know that to find k, we need to find the gradient of the line of best fit. So first we need to draw a line of best fit, which will best represent the points that we have. So I think that will do. And when you get a graph with points like this, you want to make sure the line of best fit goes through the whole graph, so you can get the most accurate results and points. So now we need to find the coordinates of the top point and the bottom point to get the most accurate results. So first we need to find the coordinate of the top point, which is so 2, 9, 5, 6, and over here will be 0, 0. And so we do the change in y over the change in x, so it will be the change in force over the change in extension. So you do 6 minus 0 and all of that over 295 minus 0. But we can see that the extension is in millimeters, but we have to change that to meters. So to go from millimeters to meters, we have to times it by 10 to the power minus 3. And when we do that, we will get we get 20.3. But we mustn't forget the units. So as we did the change of force over the change of extension, you know that it will be newtons over meters, as we change the millimeters to meters by timesing it to the 10 to the power of minus 3. So we know that the unit is going to be newtons per meter. So we have 20.3 newtons per meter. And that's the answer. So now we are going to be going over another question, which is a tangent example, where the question is determine the acceleration of a skydiver when t equals 4 seconds. So we have a graph with a y-axis of v, velocity, and an x-axis of t, seconds. So to find acceleration, we know that the formula is a, which is acceleration, equals v over t, where v over here is the y-axis and x is the x-axis. So we need to find another gradient of a tangent in this example, as the graph is a curve at t equals 4 seconds. So we need to get the point of 4 seconds and we need to make a tangent. And that's the tangent. You want to make it as big as possible so you could get the most accurate results and answers. So we need to find the coordinates. So we're going to have 35, which is the y-axis, and we're going to have 10, which is the x-axis. And over here we're going to have 0, which is the x-axis, and 20, which is the y-axis. And then we have to do the change in y over the change in x. So the change in v over the change in t. So we do 35 minus 20, and we do all of that over 10 minus 0. So when we do that, we will get 1.5 meters per second squared, as that is the unit for acceleration, and that's the answer. Remember not to forget the units. So now we are going to be going over the next example, which is a logarithmic graph example, where it states that the relationship between n and d is in the form of d equals pq to the power of pn to the power of q, where p and q are constants. And the question is, determine p and q for this data using a graphical method. Use the additional columns for your process data. So now we need to write this equation they've given us, which is d equals pn to the power of q. We need to write that in the form of y equals mx plus c. And to do that, we need to take logs on both. We need to do logs on both sides. So log d equals log p n q. And it still isn't in the form of mx plus c, so we need to use log rules to change that into mx plus c. So if you do that, we will get q log n plus log p. So now, as you can see, that mx is q log n, where q equals m and p equals log n, and c is log p. So now, as we know that y equals to log d and x equals to log n, we need to find log n and log d to draw graphs. So we know that log n is going to be x and log d is going to be y. So now we need to find the logs of the values of n and d. So log 1 is what we need to do first. So log 1 equals 0. Log 2 equals 0.3. Log 3 equals 0.48. Log 4 equals 0.6. Log 5 equals 0.7. And now we need to do the log d column. So log 5.13 equals 0.71, 7.08, 0.85, 8.71, 0.94, 10.23, 1.01, and 11.48, 1.06. So now first we need to label the graphs. So the x-axis will be log n and the y-axis will be log d. And as it's in millimeters, we need to times it by 10 to the power of minus 3 to get it in meters. So now we need to label it. So first we're going to do the x-axis starting from 0. So 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. And now we need to do the y-axis. So a misconception is that we need to start from 0 as well, but we can start from just below 0.71, which is our lowest value. So we're going to be starting from 0.65, 0.7, 0.75, 0.8, 0.85, 0.9, 0.95, 1, 1.05, 1.1, 1.15, and 1.2. And yeah. So now we just need to plot our points. So 0 and 0.71 is going to be somewhere here. 0.3 and 0.85 is going to be there. 0.48 and 0.94 is going to be here. 0.6 and 0.101 is going to be here. And 0.7 and 0.6 is going to be here. So now we need to draw a line of best fit for these points. And we need to ensure that the line of best fit goes throughout the whole graph. So the line of best fit is over there. So now, as we have drawn the line of best fit, we need to find P and Q. So Q is going to be the gradient, so we need to find the gradient of the line of best fit. And log P, we need to find P by first finding the y-intercept. So we need to find the coordinate of the highest point and the lowest point for the gradient. So the coordinate of the highest point is 0.8 and 1.105, and the lowest point is 0.71. So we need to do 1.105 minus 0.71, and you have to times all of that by the power of minus 10 to the power of minus 3 by 10 to the power of minus 3, as we want to have it in meters. And now we need to do 0.8 minus 0, and when we do that we will get 1.05 minus 0.71 times by 10 to the power minus 3, and all of that over 0.8. And when we do that we will get we will get 5 times 10 to the power of minus 4 meters. So now we need to find P, and we know that log P equals to 0.71, as that is where the y-intercept is, and to get P by itself you need to do 10 to the power of 0.71, as it is log 10 P, and when we do that P will equal to 10 to the power of 0.71. We'll get 5.13. So now we just need to write it over here. So P will equal to 5.13, and Q will equal to 5 times 10 to the power of minus 4 meters. So there you have it. Thank you for watching this video. I hope you have learned something from this video, and it would be really appreciated if you could share this video and subscribe. Have a fantastic day.